Hello everyone, this is Venkat Lakshmi Kottapalli. My CW ID is 50369283 and today's my Python project title is Life Expectancy Prediction using Navy-based classifier. So the introduction for my topic is the life expectancy is a core metric that indicates the overall health of a population. So, it is affected by various factors such as income, education, access to healthcare, immunization, and disease rates. So, our objective in this project is to build a model that classifies life expectancy into three levels, that is, low, medium, and high. So, in this, I used supervised machine learning to uncover relationships between input features and life expectancy outcomes. So, the classifier used is NAE basis, which assumes feature independence and is efficient for multi class problems. So, this project uses World Health Organization's real world global health data to build and evaluate the model. So, by categorizing life expectancy instead of predicting the exact number, we simplify the task into a classification problem. So, this approach allows for quicker insights and potentially actionable predictions in global health analytics. So, coming to the dataset overview, the dataset was sourced from World Health Organization as I previously mentioned, and it is publicly hosted on Kaggle. So it includes 2,938 observations from 193 countries and spans the years from 2000 to 2015. So each record contains 22 features ranging from health indicators like alcohol consumption and immunization to economic factors like GDP and income composition. So the target variable is life expectancy, which was continuous and later categorized into three classes. So the dataset includes both numerical and categorical values such as status. So it features like BMI, HIV or AIDS and schooling show potential impact on longevity. So the data is well structured and suitable for a classification task. And in overall, it provides a strong foundation for predictive modeling in public health. And coming to the data cleaning, to ensure the quality of analysis through data cleaning was performed. So, column names were stripped of unnecessary white space to avoid key errors. In this, missing values in numeric features like GDP and BMI were filled using the mean, and while categorical columns like status were filled using mode. So all categorical features were encoded using one hot encoding for compatibility with the model. So the life expectancy column was converted into three categories using binning, that is low, medium and high. In the low, it ranges from 0 to 50. In medium, it ranges to 51 to 70, and in high, it ranges from 71 to 90. So, any remaining missing values were handled approximately to avoid model base. So, the cleaned data set contained 2,938 complete rows and it is ready for modeling. So, this step ensured consistency and it is well prepared for training the data. So, after this step, we do data exploration. So, to exploratory data analysis that revealed a meaningful patterns across features. So, histograms were used to examine the distribution of variables like GDP, alcohol, and HIV or AIDS. So, a correlation heat map showed strong positive relationships between life expectancy and features like schooling and income composition, and the negative correlations were observed with HIV or AIDS and adult mortality. So, outliers in alcohol consumption and under five deaths were identified but retained due to their real world significance. So, feature distributions varied from development status, showing disparities between developed and developing countries in our data. And some imbalance was found in life expectancy categories with medium, because mostly the common category is medium, so there is an imbalance because of that. And by overall, the data exploration guided understanding of creep predictors and informed future treatment. And after this, we did feature selection. So all features were retained because of their relevance to life expectancy prediction. Even though naive basis assumes independence among features, each variable was found to contribute valuable information. So no strong multicollinearity was observed in the correlation matrix, and features such as GDP, schooling, HIV or AIDS, and polio immunization emerged as impactful. So, the simplicity of naive basis made feature selection less sensitive to interaction terms. Categorical variables were effectively handled using encoding, and numerical values were used as is. And the goal was to preserve domain relevant data without excessive pruning. And this approach allowed the model to learn from the full context of each record. After this, we did model selection. So the chosen model was Gaussian Ney basis. So it is a probabilistic classifier that works well with both numerical and categorical data. So it is a fast to train and perform surprisingly well even when its assumption of future independence is slightly violated. So Ney basis is ideal for multi-class classification, which fits our target labels of